Hello and welcome back to the afternoon session of PyCon AU. More online, completely online. We are so glad to have you back with us. As we are back, I am under strict instructions to add some hype for the Sunday activities, and let me tell you that hype is entirely warranted. There will be some really cool birds of a feather sessions. If you don't know what that is, they're like self-organized groups to talk about things that matter to you, which I hope you have a few of. And if not, I'm sure this afternoon can give you a few more ideas, as well as all of Saturday's program. There are also mentored sprints. So if you haven't done any open source development and you want to maybe give it a go and dip your toe in the water, come around. It's good to have a mentor. There are no crocodiles in the open source world, but it's nice to have a guide. And I've also heard rumors that there are unofficial rumors that there may be lightning talks coming, which will be a amazing feat of audio visual engineering, and I am terrified and hyper excited about those rumors. But first, we are here with Dr. Linda McIver, and I am not terrified, but also very excited about this talk. Linda is the founder and executive director of the Australian Data Science Education Institute, ADSI, which promotes data science and data literacy skills for Australian students with projects, real projects, authentic projects, and real impact. Linda has a PhD in computer science, and she has taught at both high school and university. And through ADSI, Linda now creates engaging data science projects to empower students to use tech and data science skills to make positive changes in their own communities. I am so excited to have you here. Dr. Linda McIver, take it away.
Awesome. Thanks so much, Nikki. As Nikki said, I'm the founder and executive director of ADSI, and we are a registered charity, so please excuse the blatant begging for cash that you'll see on every slide. Under instructions to do that. My board would be disappointed with me if I didn't. So today I want to talk to you about the importance of heresy. I'm going to take you through the place of heresy in science, as well as the phenomenon known as survivorship bias, and how these relate to the extraordinary claims being made in the field of AI. And then I'm going to talk about how I'm aiming to fix it all. Much of our science, technology, engineering, and maths education stems from a foundation of facts and known answers. This teaches our kids that the point of STEM is to get the right answer, whereas the actual point of real-world STEM disciplines is to fix things, understand things, and solve problems. So in this talk, I'll tell you why I founded the Australian Data Science Education Institute, why we're dedicated to raising heretics, and why heresy is something we desperately need right now, both in data science and the world as a whole. So let's define our terms. Heresy is an opinion profoundly at odds with what is generally accepted, and heresy has been crucial to our scientific development. Let's talk about some historical scientific heresies. In the 1840s, Ignaz Semmelweis came up with the radical heresy that doctors washing their hands before and indeed after surgeries prevented disease. Prior to this, doctors went from autopsies to childbirth without washing their hands or changing their clothes, and they wondered why people died. The idea that this could cause disease was considered so ludicrous that it took decades for the idea of washing hands to be accepted. And by the way, Semmelweis was so ridiculed and pilloried that his colleagues committed him to an asylum where he was beaten and died. In a well-known heresy, Galileo Galilei so outraged the church with the idea that the earth revolves around the sun rather than the other way round that he was accused of literal heresy and committed to house arrest, and he only narrowly escaped death. In 1917, Alice C. Evans made the laughably heretical suggestion that milk should be heated to a high temperature, or pasteurized, to kill bacteria that could be harmful to humans. She was not taken seriously, being a woman and without a PhD, which, by the way, weren't offered to women at the time, and it took over a decade before milk was regularly pasteurized in the US. Incidentally, after her discovery, but before its acceptance, Alice became significantly ill with undulant fever, which is one of the diseases caused by one of the bacteria found in raw milk. In the 1940s and 50s, Barbara McClintock discovered that genes aren't static sets of instructions passed from generation to generation, but that they can be regulated, turned on and off, by other parts of the genome. She described the reaction to this discovery as puzzlement, even hostility, but in the end her research changed our understanding of genetics radically. More recently, Marshall and Warren's original paper on ulcers being caused by bacteria rather than stress was rejected, and indeed vehemently rejected, consigned to the bottom 10% of submissions. Barry Marshall eventually drank Helicobacter pylori, which is the bacteria that causes ulcers, to prove it, thus inducing an ulcer which he then cured with antibiotics. So it seems like heresy is a pretty dangerous business. In fact, a lot of scientific breakthroughs have been considered heretical, especially in medicine. So now I want to digress for a moment to tell the story of the World War II planes that were examined for bullet holes to work out where to armour them. So this is the planes that made it back from battle. And researchers figured that the places with the most holes, which were the wings and the fuselage, needed the most armour. They found no holes on engines or fuel tanks, so they figured they didn't need armouring, until statistician Abraham Volt pointed out that the planes they were studying were the ones that made it back. The planes needed armour where none of the planes had holes, because clearly the planes that had holes in those other places, remember the engine and the fuel tanks, were the ones that didn't come back. I love this story because it's a classic example of the obvious conclusion being dead wrong, as it so often is when you're dealing with data. In similar results, the introduction of helmets in World War I resulted in more head injuries being treated in the field. So the first reaction was, oh my God, we have to stop using helmets. But what was the missing data? Well, what was missing was the people were not dying anymore. So they weren't looking at the death rate, they were only looking at injuries. Injuries went up, death rate went down. So both of these are examples of survivorship bias, where there's a chunk of data missing from the study. In these cases, it's literally survivor bias because it fails to take into account the people who don't come back or the planes that don't come back. So now I want to talk about AI. I want to know if you've heard of a company by the name of HireVue. They're a human resources tech company that uses artificial intelligence to select or reject candidates in job interviews based on nobody knows. They say it's a machine, therefore it's without bias. If I had a live audience here, I'd have to wait for you to stop laughing. And you can snort, but over 100 companies are already using it, including big companies like Hilton and Unilever. Which is really just all kinds of disturbing when they make these claims for it, but can't actually explain how it's making its decisions. They say that the system employs superhuman precision and impartiality to zero in on an ideal employee, picking up on telltale clues a recruiter might miss. But they won't tell us how their algorithm works, partly because it's a trade secret and partly because they don't know. And I'm fairly confident that I'm not the only person here who finds that incredibly disturbing. And the quote on the slide, it comes from a senior HireVue executive. Apart from the use of the term database as a verb, which makes me twitch, they say that humans are inconsistent by nature and they inject their subjectivity into the evaluations. And I'm not going to argue with that. But then it says the AI can database what the human processes in an interview without bias. There's no evidence for that at all. In fact, there's a lot of evidence to the contrary. And now humans are believing in machine decisions over human feedback, which is so worrying. Luke Stark, who's a researcher who studies emotion and AI at Microsoft, describes this as the charisma of numbers. If an algorithm assigns a number to a person, we can rank them objectively, right? Because numbers are objective and simple. What could possibly go wrong reducing a complex and multifaceted human being to a simple numerical rank? Hello, ATAR. And I think Cathy O'Neill sums it up beautifully. Models are opinions embedded in mathematics. An algorithm is an opinion formalized in code. It's incredibly important that we dispel this pervasive myth that algorithms are unbiased, objective statements of truth. The whole HireVue system is a textbook example of survivorship bias because they're looking only at the people who made it through the same hiring process that we're now calling fatally flawed, and thinking that we can predict ideal new hires with only that data because the system is trained on the people who made it through initially. So it completely ignores the people who didn't make it through the initial processes, who might have been amazing. It also highlights an issue I've seen raised again and again in works like Weapons of Mass Destruction made by humans and Automating Inequality, which is that people believe in numbers, computers and algorithms over other people, even when they've been explicitly told that those systems are broken. And I have a story about that too. Niels Wouters, who's a researcher at Melbourne University, some years ago designed a system called Biometric Mirror. It was a deliberately simple, utterly naive machine learning system that took a picture of the user's face and then claimed to be able to tell a whole lot about that person just from that picture. So the system spat out a rating of ethnicity, gender, sexual preference, attractiveness, trustworthiness, all kinds of stuff. And Niels created the system to start a conversation with people about how transparently ludicrous it was to believe a system that does this. So he set up booths where people would come, have a photo taken, and read all of this obviously false information about themselves. Caucasian people labeled as of Chinese origin, Chinese people labeled as Caucasian origin, patently wrong. And then he'd have a conversation about trust and ethics and the issues with artificial intelligence. So a really noble goal. I love it. But there are two postscripts to this story that are horrifying in their implications. First of all, Niels would overhear people walking away, having had the conversation about how obviously false the conclusions drawn were, saying, but it's a computer. It must be right, and it doesn't think I'm attractive. And secondly, after speaking publicly about all the issues with Biometric Mirror, Niels was contacted by not one but 3 human resources companies wanting to buy it. Here is a system which is broken in all kinds of transparently obvious ways, and everybody wants to use it. So here is where we start to make the connection between education and the tech industry, because one of the problems with data science is that we often don't have a lot of time to challenge even our own results, never mind anyone else's. The rush to data riches, step 3, profit, means that we don't really have time to be cautiously skeptical. We get a result, report it, and move it on to the next data set. And people are all too willing to believe in those results. So when I gave this talk in a room full of data scientists, I said, hands up if you've ever had to release or report on a result that you felt hadn't been fully tested and that you couldn't bet your life on. And about half the hands in the room went up. And then I said, hands up if you think there'd be more hands up if we'd done this via an anonymous poll. And pretty much every hand in the room was up. So all of the discoveries that I talked about in the first half of this talk were made by people being skeptical, and we need that in data science. We need to challenge the status quo. We need to question accepted wisdom. Those discoveries were made by people who are quite prepared to examine new evidence and consider that what everybody knows, might be wrong. Of course, we need educated heretics so that our skepticism is rational and fact-based and not anti-vax and climate change denying. So education is clearly key. But think about STEM education as we often see it today. We mostly teach science, technology, and maths in schools as a matter of facts and known outcomes. And yes, I know there's one more letter in STEM, but we very rarely actually teach any engineering. So consider your average chemistry experiment. We take known substances, we apply a known process, and achieve an expected outcome. What do kids who don't get the results they expect do then? Do they go back and try to find a reason for their results? Do they ask questions and challenge outcomes? They very rarely have time for that, and they get no credit for it. So they copy their friends' results, or they simply adjust the results to get the outcome they expected to get. And there's a name for that. Marks are allocated for the expected results, for the right graph. Occasionally, we run a prac with unknown reagents and ask the students to identify the inputs, but here again, marks are for the correct answer. That's an education in confirmation bias, not in science. So in finding what you expect to find, in seeing what you expect to see, that's how we're teaching science. We're teaching kids to get the right answer. It's the exact opposite of the way science should work. Science should be about disproving theories, and you only accept a theory as plausible when you've tried your hardest to disprove it and failed. And unfortunately, maths education is much the same. The emphasis is on correct answers and known outcomes, on cookie-cutter processes that produce the same result every time. Now let's talk about tech education, which is often even worse. With the severe shortage of teachers with programming skills, we tend to default to education using toys. So we draw pretty pictures, we make robots follow lines, and everybody writes the same code and produces the same output. What if we could teach with experiments where we don't know the answers? Well, with data, we can easily do that. Can we find a data set that hasn't been fully analysed and thoroughly understood? I could probably hit a dozen with a bread roll from where I'm standing. But how do you mark it if you don't know the right answer? Well, you mark the process. You mark the testing. You ask the students to test and challenge their answers really thoroughly, and you give points for their explanation of why they believe that their answer is right, and how they confirmed it by trying their hardest to prove it wrong. It has been said, most famously by Grace Hopper, that the most dangerous phrase in the English language is, "We've always done it that way." And now more than ever, we need people who challenge the status quo, who come up with new ideas, and who are prepared to be heretical. The trouble is, teaching data science in the context of real projects takes time. But by doing it, we can actually teach kids to challenge their own thinking and their own results. We can teach them to think critically and analyze the information they're presented with. And we can teach them to demand higher standards of validation and reproducibility. But as I said, it takes a significant amount of setup work. And the only reason I was able to do it was because I was part-time. So for example, when I downloaded a vote data set from the AEC, the Australian Electoral Commission, and tried to find someone who could explain to me how the two-dimensional Senate ballot paper translated to a one-dimensional data string, I literally couldn't find anyone who knew. No one at the AEC. I mean, presumably there is somebody somewhere, but I couldn't find them. It took me hours and hours to make sense of the data set. I had to go back to first principles and try to figure out how it mapped, how one mapped to the other. And a teacher who's full-time doesn't have time for that kind of stuff. So I used my own time. I was part-time and I used my own time to build these projects. In year 10, we did projects on climate, on elections, on microbats, not microbits, microbats, these cute little furry guys with their crazy teeth. In year 11, we worked with scientists to solve their computational and data needs in fields like marine biology, conservation ecology, neuroscience, astrophysics, and physiology. And the possibilities are truly endless. But a teacher with a full-time load doesn't have the capacity to take on that kind of work. It's just too time-consuming, even if they have the skills to start with, which they usually don't. So that's why I created ADSI, to develop project ideas and lesson plans that empower kids to explore data and become rational skeptics, to develop their data literacy, critical thinking, and technical skills in the context of projects they really care about, and also to provide professional development training to teachers right across the curriculum, not just digital technologies teachers, but teachers history, geography, science, maths, English, everything. The goal is to integrate real data science into their teaching, to use data to make sense of the world. At ADSI, we've created projects where kids use real data sets to solve problems in their own communities and their own environments, and most importantly, to measure and evaluate their solutions to see if they worked. So we've got projects that do things like calculate how much carbon is embodied by the trees on the school grounds and then do comparisons of the school's carbon emissions from electricity. Or construct a set of criteria for good science journalism and then evaluate a bunch of different sources according to those criteria and visualize the results. I'm going to skip ahead. You can go and look at all of these projects on the ADSI website. So when I was teaching computer science at John Monash Science School in Melbourne, which is a school for kids who are passionate about science, who you might be forgiven for assuming were already engaged with tech, we started by teaching them with toys. We had them draw pretty pictures and program robots to push each other out of circles. And the number one piece of feedback we got was, this isn't relevant to me. Why are you making me do this? I'm never going to use it. And when we shifted to teaching the same coding skills in the context of data science, using real data sets and authentic problems, that feedback disappeared. Instead, they were saying, this is so important, this is so useful, I'm using this in my other subjects. And the best thing was, I didn't know I could do this. We heard that a lot. So not only does teaching tech skills in the context of data science teach the kids that STEM skills empower them to solve problems and find out more about their own world, it gives them the motivation to succeed, to actually learn the skills and put them to good use. And make no mistake, motivation is the single most important factor in learning. One of my friends who works in data science recently met someone who, on learning her occupation, literally said to her, "You work in tech, so are you on the spectrum?" Because if I asked you to picture a computer scientist or data scientist, well, not you, but most people, they'll probably imagine someone like Sheldon. Current figures suggest that women make up as little as 15% of the data science industry. So it's lack of diversity in the industry that leads to systems like HireView, because there are no voices in the room prepared to say things like, have we really thought this through? And what are the ethical issues? So ADSI's work isn't going to turn every student into a data scientist, but it will give kids the option of being data scientists who wouldn't have had it otherwise. And it will give kids tech skills who wouldn't have had them otherwise, because they'll understand the power of data science and they'll know that it's something they can do. And that is phenomenally empowering. Thanks very much. Ask me your questions.
Fantastic. Thank you very much, Linda. There have been some really interesting comments and conversations happening in the thread. I've got a few of them. As is untraditional, I'm going to start with some of the comments. Early on, people were saying on you're talking about algorithmic bias. Thanks, I hate it. And that we need a crying emoji in the reactions. But one of the questions that came up late in the set was that in terms of diversity, someone wondered if these real-world data sets might help with the often wonky gender balance in STEM classrooms in high schools.
Massively. So when I was teaching, I had a year 10 class, which everyone had to do, and a year 11 computer science class, which was optional. I went from 5 girls in that computer science to 10 the first time we did data science as a project. And one data point does not make a trend, but it's a start. And the interesting thing is that we also got a lot more boys. So the class got much bigger. So we were not only getting the girls, we were getting the boys who hadn't been interested before. And that's a kind of undermeasured and perhaps unmeasurable part of our diversity problem, which is that we tend to get the people we've already got, or the kinds of people we've already got. And some of those people that we're not getting are boys as well as girls.
Absolutely. So any improvements to this, I think, improve everyone's experience with it.
Exactly.
One of the other questions, I think we've got time for one, maybe two more, is how technical do you get in your classes? Do you assume that there's Python knowledge or teach from first principles? Do you use pandas?
Excellent question. Mostly we use spreadsheets, not even Python. When I was teaching it, I did Python because I could. But a lot of the teachers I work with don't have any coding skills and in fact aren't even very confident with spreadsheets. So we really do very, very basic levels of data science. We look at outliers, we look at averages, we look at the difference between average versus median. We do very, very simple graphs. I'm not doing any machine learning. I'm not using pandas. I'm not doing any k-means clustering, or it's almost a stretch to call it data science. It really is basic data skills and data literacy. With the teachers who are ready for it, we do Python, but there's not enough of you.
Well, we're helping to try to grow that pool, certainly.
That's right.
One question that should be relatively quick to answer is there a copy of this talk, because it's pretty awesome, that I can distribute to my teacher friends? The easy answer to that is that this talk is recorded and will be put on YouTube imminently in the next few days. So you'll be able to share this talk with all of your other teacher buddies and data science buddies, and also the people you think maybe need to listen to it rather than would enjoy it.
And there is a text version of it on the Etsy blog as well.
Fantastic.
And there's also a book coming which is entitled Raising Heretics, so keep an eye out for that if it doesn't kill me in the process.
All the different mediums. Do you have a SoundCloud as well, perhaps?
No, nobody needs that.
We've got one more minute. One interesting question that came up in the middle was that how do students react to going from teaching for a specific answer, a defined answer, to more exploratory do they complain about a lack of direction?
Well, that's an interesting question, a really good one. A lot of the kids take it and run with it. So with the Electoral Commission data set, for example, I said, find your own question that this data set could answer. And so there's the whole conversation around what questions does it answer. And of course, the first thing they all said was, it tells me which is the best party. And sadly, I don't believe the votes actually show that. But then you have that conversation around qualitative versus quantitative. And then you do have to have some backup questions for the kids who are just like, I can't find my own question. Let's just, head explode thing. You have to inch them towards it, some of them. And so you scaffold it, you get them, you ask them about their own electorate and, zero in on something they'd like to know or something they've noticed about people around them, that kind of stuff. You have to take it slowly with some kids.
And maybe if we start this earlier, we'll all get used to it, both students and teachers.
Exactly, which is why I focus on primary school. I do primary school and secondary school, but the primary school stuff is really important because we've lost them by the time they get to high school, often.
Great. Well, that is just about all the time we have for these questions. But Linda will jump back onto the chat and answer all of the questions there for the next few minutes, and then you can jump into the hallway track. Thank you so much again. And we are up next in 10 minutes with Kenny Borden, who's going to talk about walled gardens for growing students. So we shall see you all back here in just a few. Thanks very much.
Beautiful. Thanks, Nikki.